Hello everyone! We're Math Together Canada, and this is the first video in our problem-solving series. My name is Perry, and with me today are my co-executives James, Kaylin, and Michael. Today, we'll be going over the first 4 problems from the 2024 Euclid contest hosted by the University of Waterloo. Without further ado, I'll pass it off to James to start us off.
Starting with question 1. So Euclid questions tend to be pretty easy up until around question 5 or 6, in which it might require a bit more thinking. So this shouldn't take too long to get through the first few questions. So if x equals 2, what is the value of x power 4 plus 3x squared divided by x squared? So one thing you might do is just immediately substitute the values in. You can do 16 plus 3 times x squared, which is 3 times 4, so it's 12, divided by x squared, which is 4. And then you can get 7. I'll write that just so it's clear. But another way is just to simplify the expression first by dividing the numerator and denominator by x squared, because the numerator is a multiple of x squared. So you can get that this expression is also equal to x squared plus 3. And note that you're not dividing by 0 here, because you're given that x equals 2. So make sure you don't divide by 0 in questions like these. And since x equals 2 here, you can just plug x equals 2 in and get 7 as well. So yeah, you can either immediately plug it in and then get a value, or just simplify it first. Moving on to question 1b then. You have a triangle that is right angled at B, with AB equals 10, BC equals t minus 1, and AC equals t plus 1. So this, as many of you may already know, is just an application of Pythagorean theorem. So you have AB squared plus BC squared is equal to AC squared, because angle ABC is equal to 90 degrees. And then if you just plug in the values that you're given, right, 100, which is 10 squared, plus t minus 1 squared, that is equal to t squared minus 2t plus 1, is equal to t squared plus 2t plus 1. And then you note that since there's a t squared on both sides, you can immediately cancel that out. So to simplify the expression, you cancel out the t squares on both sides. And then you have plus 1 here, so you get 101 as a constant term. You still have minus 2t here, is equal to 2t plus 1. Now, we can just move all the t's over to the right-hand side and get 100 is equal to 4t. And then you can get that t is 100 over 4, which is 25. So that should be question 1b. Now let's move on to question 1c. You have 2 divided by y plus 3 divided by 2y is equal to 14. So determine the value of y. For this question, what you can first do is put everything under a common denominator. So you have 2 over y is equal to 4 over 2y by multiplying numerator and denominator by 2. And then you also have 3 over 2y here. You don't change that. So this is the left-hand side. And since these two fractions have the same denominator, you can combine the numerators. So you get 4 plus 3 equals 7 as the numerator and 2y as the denominator. And this is equal to the right hand side, which is 14. Now, if you multiply both sides by 2y, or move the 2y to the right hand side, which you can do because y is clearly not 0, otherwise like y and 2y would be 0, and that would not be possible. So multiply both sides by 2y to get 7 equals 28y, and then you can just divide both sides by 28 to get y equals 7 over 28, or after simplification, it's just 1 over 4. So yeah, question 1a, the answer is 7. Question 1b, you have 25. And question 1c, have 1 over 4. So now let's see if Perry wants to do question 2.
Okay, let's take a look at question 2 then. So let's move down. Oh, could somebody paste the question 2 problems into the whiteboard?
All right. Okay.
All right, thank you.
Here.
Just move that down. All right, so this is question 2 from the 2024 Euclid. All right, question 2a asks about a sequence with 6 terms where each term after the second is the sum of the previous 2 terms. And we're given the 4th term and the 6th term, and we're asked to figure out what the first term is. So let's write down all of this information. We have a sequence of 6 terms. So draw this over here. That's six terms. And we know that the 4th one is 13, and the 6th one is 26. Sorry, not 26, 36. We're also given that each term after the second is the sum of the previous 2 terms. So let's set variables a and b to be the first 2 terms. Then what we can do is we can get that the 3rd term is going to be a plus b. And then the 5th term is going to be a plus b plus 13, because it's the sum of the 4th term and the 3rd term. Thus, we now have a few equations from these 2 numbers, since we know that 13 is going to be the sum of the 2 before it, and the same for 36. Thus, we have that 13 is equal to b plus a plus b, and 36 is equal to 13 plus a plus b plus 13. Now, the question asks for the first term, which is a, so now we can just solve the system of equations to get what a is. This is equal to 2b plus a, and this one is equal to 26 plus a plus b. We can simplify the second equation to get that. This becomes a plus b equals 10 after you move the 26 to the 36, and a plus 2b is equal to 13. If we subtract these 2 equations, then what we get is that b is equal to 3 and a is equal to 7. And so this would give you the answer of a equals 7, but let's just check our work. So we get the sequence 7, 3, 10, 13, 23, 36, which matches our initial assumption. So the answer is a equals 7. Alright, let's move on to 2b. Do that part over here. Okay, so this was 2a. And so 2b. For some real number r, the sequence from 5r to 5r squared to 5r cubed has the property that the second term plus the third term equals the square of the first term. So this question sets up an equation that we have to solve. So the second term is 5r squared plus the third term is 5r cubed. This is equal to the square of the first term. Notice that the question says that r is not 0, so we'll be able to cancel powers of r from both sides of this equation. Let's expand the right-hand side so that this becomes 5r squared plus 5r cubed is equal to 25r squared. We can combine like terms to get that 5r cubed is equal to 20r squared. Since r is not 0, we can divide both sides of this equation by r squared. We can actually also divide both sides by 5, since 5 divides 20. This gives us r is equal to 4. And we can once again check that this satisfies our given equations. I'm not going to do that here, but this is our final answer. And so finally, we have 2c. So Jimmy wrote 4 tests. The average of his marks on the first, second, third was 65, second, third, fourth was 80, and his mark on the fourth was 2 times his mark on the first. Okay, so let's let his marks on the first, second, and third be, so this is test 1, 2, 3, 4, and say he got a mark of A, B, C on the first 3. Then we also know that his mark on the fourth test was twice his mark on the first test. So this is 2a. So now what equations do we have? We have that the average of the first 3 tests is 65. What does this mean? This means that a plus b plus c over 3 is equal to 65. So we can multiply both sides of this by 3 to get a plus b plus c is equal to 195. We also know that the average of the second, third, and fourth test was 80. Therefore, b plus c plus 2a over 3 is equal to 80. Once again, we can multiply both sides by 3 to get the equation b plus c plus 2a is equal to 240. Now, the question asks us for his fourth test mark. Therefore, what we can do is note that both equations have this b plus c term, where they only differ in the coefficient for a. Therefore, if we just subtract the 2 equations, we should just be able to get a. And indeed, we do get that when subtracting, the b plus c's cancel, and you get 2a minus a is equal to 240 minus 195. And this gives a is equal to 45. Now, just be careful here, and because the question asks for his mark on the fourth test, which is actually 2a rather than a. Therefore, our final answer is 2a, which is equal to 90. And yeah, that's question 2 on the Euclid. So now I'll pass it off to Michael to do the next question.
Okay, yeah, let's proceed by problem 3. Part A, we have this quadratic equation intersects the y-axis. And when it intersects the y-axis, that's when x equals 0. Okay? So because x equals 0, and we know that here y must equal 48, so we can just plug it into the equation. So y equals r times 0 minus 3 times 0 minus r is equal to 48. And now we can just expand it. So r times 0 minus 3 times 0 minus r, that's equal to r times negative 3 times negative r. That's equal to, the negatives cancel, double negatives equal positive, so 3r squared is equal to 48. So that means r squared, we divide both sides by 3 because we want to isolate the variable. So we get r squared is 16. And the two possible values are just the values that r squared equals 16, so it's plus minus 6, plus minus 4. Okay, now we can proceed by part B. So this bicycle costs this amount of money before tax. Sales tax was 13%, and this guy would like to pay a total that is for $24 higher than the sale tax was 5% was value B. So yeah, we know that if the sales tax was 13%, that's 24 more than if the sales tax was 5%. So if the sales tax was 13%, then it would cost 13% more. So it costs more. So that is B times 13% is 0.13. So total cost would be B times 1.13. And if the sales tax is 5%, we can do the same thing to get the cost would be B times 1.05. Now we're given that this is 24 higher, right? 24 higher. So what we can do, we can subtract the two to get 24. So B times 1.13 minus B times 1.05 is equal to 24. So that means we can group the B's. The remaining is 1.13 minus 1.05 is equal to 24. Right. And here we can do B times 1.13 minus 1.05, that's just 0.08 equals 24. And then we can divide both sides by 0.08. So B equals 24 over 0.08, and that is easy. You just evaluate that. That's equal to 300. So it's 300. So now we can proceed by part C. We have this function and we have some properties about this function. So we can like do a table of values, right? So we can like procedurally find f of 2, f of 3, and f of 4, right? So first we can start by finding f of 2. We know from here that f of 2 times 1, we need an equation for f of 2 to find f of 2, right? So we can use this one, 2n equals 2, that's n equals 1, so that's equal to f of 1, and that is equal to 3 squared, which is 9. And then we can find f of 3, and notice you can't use the first that equation anymore, because 2n means 2n is like an even integer, but 3 is not. So we can use this one instead. So f of 2 times 1 plus 1, this is when you sub in m equals 1. So that's equal to 3 times f of 2 times 1. That's equal to 3f of 2. That's equal to f of 2 is 9, so it's 3 times 9, which is 27. And then we can find f of 4. We can use this one again. We can use this equation again. So 2n, we want an equation for f of 4 to find f of 4. So to get that equation, what we can do is we can let f of 2n equals to like f of 4. So that's when n equals 2, right? So f of 2 times 2, that's when n equals 2 is equal to f of 2 squared. And that is equal to f of 2 we have found here, that is 9. So that's 9 squared, which is 81. So f of 2 plus f of 3 plus f of 4 is 9 plus 27 plus 81. And then we can evaluate that. That's just 117. So that is problem 3 done. Now, Kaylin, would you like to continue by problem 4?
Okay. Okay, so this is question 4. So for part A, in the diagram, AB is perpendicular to CD with B on CD. CP is perpendicular to AD with P on AD, and N is the point of intersection of AB and CP. And you're also given these angles and lengths. So you want to find the area of triangle APN, which is this thing over here. Okay, so first we know that CB is equal to 6, so we can label that. And angle ADB, which is this angle, is equal to 45 degrees. So, given that angle CPD is equal to 90 degrees and angle CDP is equal to 45 degrees, you know that angle PCD is also equal to 45 degrees. And then given that, you know that angle CNB is also equal to 45 degrees. So that means that NB is equal to CB, which is 6. And then AB is equal to 12 and NB is equal to 6. So that means that AN is also equal to 6, which is 12 minus 6. And then because you know that angle BDA is 45 degrees and angle ABD is 90 degrees, then you know that angle BAD is 45 degrees. And then after you know that, you can see that angle ANP is also equal to 45 degrees. So that means that triangle APN is a 45, 45, 90, or 1, 1, root 2 triangle. So AN is equal to 6, so that means that AP is equal to PN, which is equal to 6 over root 2, or 3 root 2. So then, the area, I'm going to write it up here. So the area of APN is equal to AP times PN over 2, which is 3 square root 2 squared over 2, which is equal to 9. So that is our final answer for 4A. Okay. So for the next question, 4B, in the diagram, the line with the equation y is equal to negative 3x plus 6 crosses the x-axis at A and the y-axis at B. Suppose that m is greater than 0 and the line with the equation y is equal to mx plus 1 crosses the y-axis at D and intersects the line with the equation y is equal to negative 3x plus 6 at C. So we're given that O is the origin and the area of ACD is 1/2 the area of ABO, and we want to find the coordinates of point C. So first we can look at the line y. Oh, what happened? Okay, we can look at the line y is equal to negative 3x plus 6. So the y-intercept is b, so b is equal to the y-intercept. So that is when the x value is 0. So if we plug in x is equal to 0 to this equation, y is equal to negative 3x plus 6, then we see that y is equal to 6. So that's what point B is. And for A, it's the x-intercept. So that's basically when the y-coordinate is 0. So plugging that in, 0 is equal to negative 3x plus 6, so x is equal to 2. So now we know that the area of triangle ABO is equal to OB times OA divided by 2, which is equal to 6 times 2 over 2, which is 6. So the area of ACD is equal to the area of ABO over 2, which is 6 over 2, which is 3. So then now we know that the area of ACD is 3, so we can label that. We also know that OA is equal to 2, so now we find where point D is. So let's look at the line y is equal to mx plus 1 now. So D is the y-intercept of this line. So if we plug in x is equal to 0, then we see that y is equal to 1. So that means that OD is equal to 1. So the area of ADO is AO times OD over 2, which is 2 times 1 over 2, which is 1. So now we can label these two areas as well. And we know that DO, the length of DO is 1. Why is it? Okay, whatever. The length of DO is 1, and the length of DB is 6 minus 1, which is 5. So now we just look at triangle DCB. So the area is equal to 5, and we know that not 5, 2, and dB is equal to 5. So the area of DCB is equal to half of dB times, so we can draw a perpendicular line from C to BD, and we can call that point E. So it would be half of dB times CE. So this is equal to 2. So that means that CE is equal to 4 over dB, which is equal to 4 over 5. So that means that the distance from C to the y-axis is equal to 4 over 5, which means that point C's x-coordinate is 4 over 5. And we still don't know its y-coordinate, but we can find that out by plugging this value into y is equal to negative 3x plus 6 because C is on that line. So y is equal to negative 3x plus 6, which is negative 3 times 4 over 5 plus 6, which is negative 12 over 5 plus 6, which is 18 over 5. So now we know that x is equal to 4 over 5 and y is equal to 18 over 5. So point C's coordinates are 4 over 5 and 18 over 5. And that is our final answer.
If you've made it this far, we hope you've learned some new problem-solving ideas and strategies and enjoyed our video. Make sure to subscribe to our channel so you don't miss out on any of our future uploads. If you have any ideas or suggestions, feel free to drop a comment below. We'll see you in the next one!